Namaskar, I am Dayan Gowde, Assistant Professor in Mathematics, Center for Distance Education, Shivaji University, Kolhapur. Today I will discuss the examples on submodules. Let M be an R modules. Define Rm is equal to summation of Ri, Mi, I is equal to 1 to M, such that Ri belongs to R, M belongs to M, and N is finite. Then Rm is a submodule of M. Solutions: let AB belongs to Rm and R belongs to R. Then A is equal to summation of Ri, Mi, I is equal to 1 to M. Ri belongs to R, Mi belongs to M, and N is finite. And B is equal to summation of Si, Ti, I is equal to 1 to T. Si belongs to R, Ti belongs to M, and K is finite. Therefore, A minus B is equal to summation of Ri, Mi, I is equal to 1 to N, minus Si, Ti, I is equal to 1 to K is equal to R1 M1 plus R2 M2 plus plus dash dash plus Rn Mn plus minus S1 T1 plus minus S2 T2 plus dot plus minus Sk T2 belongs to Rm, as R1 belongs to R minus S1 belongs to R, and the sum contains at most n plus k element. Therefore, R into A is equal to R into summation of Rimi, I is equal to 1 to M, is equal to R into Rimi is equal to R into Rimi, whereas Ri belongs to R. For each I, we get R into A belongs to Rm. Thus, from first and second, we get Rm is a R submodule of M. Next theorem, let M be an R module for any two submodule n1 and n2 of M. n1 plus n2 is a submodule of M containing n1 and n2 both. For proof, n1 plus n2 is equal to n1 plus n2 such that n1 belongs to n1 and n2 belongs to n2. Obviously, if AB belongs to n1 plus n2, then A minus B belongs to n1 plus n2. As n1 plus and n2 plus are subgroup of an abelian group M plus, hence n1 plus n2 plus is a normal subgroup of M plus. Let A belongs to R and X belongs to n1 plus n2. Therefore, X belongs to n1 plus m2. This implies that X is equal to n1 plus n2. For n1 belongs to n1 and n2 belongs to n2. Ax is equal to A n1 plus n2 is equal to A n1 plus an2, since n1 n2 belongs to M and M is a R module. Now, as n1 is a R submodule, A n1 belongs to n1, Similarly, N2 is a R submodule will imply that A N2 belongs to N2. Therefore, A N1 plus A N2 belongs to N1 plus N2. Thus, Ax is equal to An1 plus An2 belongs to N1 plus N2 for any A belongs to R and X belongs to N1 plus N2. This shows that N1 plus N2 is a submodule of an R module M. N1 belongs to N1 can be written as N1 is equal to N1 plus 0, 0 belongs to N2. Hence, N1 is subset of N1 plus N2, and similarly, N2 is subset of N1 plus N2. More generally, we get if Ni R1 less equal I less equal K is a family of submodules of a module CM, then summation of Ni I is equal to 1 to K is equal to x1 plus x2 plus dot dot plus xk such that xi belongs to Ni. 1 less equal I less equal K is the smallest submodule of M containing each Ni. R1 less equal I less equal. Now for proof, if x1 plus x2 plus xk and y1 plus y2 plus dot dot plus yk are element of S, then x1 plus x2 minus y1 plus y2 dot dot plus yk, x1 minus y1 plus x2 minus y2 plus dot dot plus xk minus yk belongs to X. Further, if R belongs to R and x1 plus x2 plus dot dot plus xk belongs to S, then R into x1 plus x2 plus dot dot plus xk is equal to Rx1 plus Rx2 plus dot dot plus Rxk belongs to S. Thus, from 1 and 2, Is is a submodule of M. Let x belongs to n, then x is equal to 0 plus 0 plus dot dot plus 0 plus x plus 0 plus dot dot plus 0 ith place. Then hence x belongs to S. This shows that Ni is a subset of S. Thus we get Ni is a subset of S for all I 1 less equal I less equal K. Hence summation of Ni is subset of S, S being a submodule of M. Let M is any submodule, any other submodule of M containing each Ni 1 less equal I less equal K, then obviously S is subset of T. From 1 to 3 we get S is the smallest submodule of M containing each Ni 1 less equal I less equal K. Hence S is equal to summation of Ni I is equal to 1 to K. Next theorem, let M be an R module. If N1 and N2 are submodule of M, then N1 intersection N2 is a submodule of M, as 0 belongs to N1 intersection N2. We get N1 intersection N2 is not equal to pi. Let xy belongs to N1 intersection N2. Then xy belongs to N1 and N1 is a submodule of M will give x minus y belongs to N. Thus xy belongs to N1 intersection N2. X minus y belongs to N1 intersection N2. Again, for any R belongs to R and in any x belongs to n1 intersection n2, we get Rx belongs to n1, Rx belongs to n2, as n1 and n2 are submodules of M. But then Rx belongs to n1 intersection n2. Thus x minus y belongs to n1 intersection n2 and Rx belongs to n1 intersection n2. Hence, n1 intersection n2 is a submodule of M. Guys,